Good morning, happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All righty, so today is our last class meeting. I will be back this afternoon for an office hour, 1:15 to 2:15. Your final exam is on Monday and needs to be completed by Monday night at 11:59 p.m. Tuesday, after all the finals are done on Monday, Tuesday I will be correcting finals, calculating grades. I will notify each one of you by email personally, telling you what your grade was in the class, whether you passed or not. Anyway, so thank you very much, and we shall continue now. We are going to be looking at chapter 11 material, and we're going to go over some questions from WebAssign. So let's go ahead and get started. All righty. There we go. Okay. Now, let's take a look. It says graph the function f of x equals 4 to the x power. F of x equals 4 to the x power. So this is in that form y equals b to the x. So the base is greater than 1, which means it's going to increase. Well, all of these functions increase. The domain would be all real numbers. All of these functions have all real numbers as the domain. The range would be greater than 0. So that means it's got to be this one, or this one. But where is the y-intercept? Well, f of 0 equals 4 to the 0 power equals 1. So the y-intercept would be at 0, 1. And the only one with the y-intercept at 0, 1 is this one. So it's got to be that one. Okay, and let's take a look at this one. Here we have a graph that's in this form, or an equation that's in that form. However, b is less than 1, which means it's got to be a decreasing function. So it's either got to be this one or that one. But again, the y-intercept would have to be at 0, 1. Let's see here. 0, 1. Well, it looks, not only that, but the domain would have to be all real numbers and the range would have to be greater than 0. So this one has a vertical shift downwards, so it doesn't have a range greater than 0. It's got to be that one. Worst case scenario, you could always plot a whole bunch of points and do it that way. Okay, let's see, where did that one go? Okay. All right, let's take a look at this problem. Assume there are no deposits or withdrawals. An account now contains $3,640 and has been accumulating interest at 4% annual interest compounded continuously. All right, so we're talking compounded continuously. Let's see what this is, number 5. So we're going to be using, that's not right, P e to the RT. Sorry, that's a strange looking P. Let me fix that. Okay. All right. So let's see. It now contains $3,640. So we're going back into the past. So the final amount is the $3,640. Annual interest rate is 4% or 0.04. Compounded continuously. That's why we're using this formula. How much was in the account 5 years ago? So we're looking for the starting amount. It's kind of a Jeopardy thing. We know the answer. What's the question? We know the final amount. What's the beginning amount? So we've got this 3,600. I need to just slow down. I'll get through all this. $3,640 equals P times e to the 0.04 times 5 power. And so if we take 0.04 times 5, we get 0.2. So now I'm going to divide both sides by e to the 0.2 power. So P equals $3,640 divided by e to the 0.2 power. 3,640 divided by e to the 0.2 power. I get 2,980, 1.179941. It says round your answer to the nearest cent. So that would be right here. One place over to the right, the 9 would round up. So we're going to get $2,980.18. So let's see here. $2,980.18. All right, let's take a look at number 6. This says the population of Earth is approximately 6.8 billion people and is growing at an annual rate of 1.133%. Use the exponential growth model to predict the world population in 20 years. All right, so A equals PE to the RT, and the beginning population is 6.8 billion. The annual growth rate is 1.133%, which would be 0.01133. Time is 20 years. So A equals 6.8 times E to the 0.01133 times 20. Okay, and this is in billions. So 6.8 times e to the 0.01133 times 20. Close that up, and we get 8.529430647. It says round to your answer to one decimal place, so that would be right there. The 2 would round down, so it's 8.5 billion. Now, a mistake I noticed that a lot of people made, they didn't put in 8.5. They put in like 8,529,430.6 or something. But notice that the units is in billions. The given amount originally is in billions. So here we want 8.5 in billions. All righty. Let's take a look at number 7. How long will it take $9,000 to double if it is invested at an annual rate of 3% compounded continuously? Okay, so the time for something to double that's being compounded continuously is the natural log of 2 over r. Remember that formula? We can use the other formula and we'll get the same result, but it'll take longer. So the time equals the natural log of 2 over 0.03, the annual interest rate. So we've got the natural log of 2, close it up, divided by 0.03. Round your answer to one decimal place. I'm getting 23.104. So that would round down 23.1 years. 23.1. Okay. Let's take a look at this one. Number 8. Solve the equation. 3 to the x plus 2 power equals 243. Well, 243 is 3 times 81, which is 3 times 9 times 9, which is 3 times 3 times 3 times 3 times 3, or 3 to the 5th power. So this problem could be written like this. Now that the bases are the same, the exponents are equal, so we get x equals 3. All right, let's take a look at number 9. Solve the equation. 5 to the 3x equals 1 over 25. 1 over 25 is 1 over 5 squared, which is 5 to the negative 2 power, moving upstairs. So 3x equals negative 2. X equals negative 2/3. Okay, let's take a look at number 10. Again, if you need me to slow down or go into more detail about something, please let me know. $550 is deposited in an account paying 8.6% annual interest, compounded semi-annually. Aha, so we're going to use this formula because it's not continuously. How long will it take for the amount to increase to $850? Okay, so the original amount is $550. The annual interest rate is 8.6% or 0.086, compounded semi-annually, so that's twice a year. How long will it take? Time is the unknown for it to increase to $850. All right. So $850 equals $550 times 1 plus 0.086 divided by 2, all to the 2t power. Okay. I need to isolate the exponential base, so I'm going to divide both sides by $550. That reduces out. Dollar signs go, the zeros go. I suppose I could take what, 85 divided by 5. What's 85 divided by 5? I think that's 17 over 55 divided by 5, which is 11. Okay, that's not going to come out nicely, so I'm going to leave it that way. Inside here, I'm going to get 1 plus, let's see, 0.086 divided by 2 is 0.043 to the 2t power. Then 17/11 equals 1.043 to the 2t power, combining those like terms, combining those numbers. Okay, so now it's in that form, exponential form, where I can rewrite it as a logarithm. So I'm going to get log base 1.043 of 17/11 equals 2t. Okay. I'm going to multiply both sides by 1/2. So I'm going to get this. I'm going to get t equals 1/2 the log of base 1.043 of 17/11 using the change of base formula, 1/2 times the log of 17/11 over the log of 1.043. So on my calculator, parentheses, 1 divided by 2, close parentheses. And then the log of 17 divided by 11, close that up, divided by the log of 1.043, close that up. 5.16990, etc. And it says to the nearest tenth, the 6 would round up, so 5.2 years should be the correct answer. Okay, let's see. This is similar. This one. Here, so number 12. The value in dollars of a certain model car is given by the function where t is the number of years from the present. Find the value of the car in 5 years. So basically, v of 5 would equal 14,000 times 10 to the negative 0.165 times 5. Okay. So 14,000 parentheses 10 to the parentheses negative 0.165 times 5, close it up. And we get 2094. 2094. 729919. And there's dollar, so that this would be money, because let's see here. So the nearest dollar would be there. That would round up to $2,095. Let's see if that's correct. $2,095. Okay. I don't know why, for some reason, I was feeling uneasy about that. Maybe I need to wear my glasses when I'm using my calculator. I keep saying that, but okay. Write the statement. This is what, number 13. Write the statement log base 4 of 64 equals 3 in exponential form. 4 cubed equals 64. Base is the same, but the players change. So we've got this. So 4 cubed, and then I've got to let's see here, move that right arrow, equals 64. Hmm. 4 cubed equals 64. So something's wrong with what I put or how I wrote that. Well, let's see here. 4 cubed. And then if I go equals, I know that's not right. I've got to move it outside of that. Equals 64. Okay, so I think what was wrong was I misused this. You've got to put the base in, the 4, then click that to put the exponent, and I clicked this first. So honestly, I haven't used this much, but you've got to get familiar with it. Okay, so here we go, number 14. Write the statement 8 to the negative 1 equals 1 over 8 in logarithmic form. So this would be log base 8 of 1/8 equals negative 1. Okay, So I've got to find the log. Let's see here. Functions, symbols, relations, sets, trig, Greek. I went past it. So I need this one, log base 8 of 1/8. I think I need to put a right parentheses there. Notice how before it was gray, and so I've got to actually put one in there to make it black, and that equals -1. This is one of the reasons you need to do your homework in WebAssign to get used to the notation, said the man who hasn't done it in WebAssign and so has to be very careful. Okay. At least I haven't done it as much as all of you should have. Do as I say, not as I do. Evaluate. Log base 3 of 9. All right. So let's see, how are we doing for time? This is equal to some unknown quantity, but now it's an equation, so I could go 3 to the box equals 9, 3 to the box equals 3 squared, so the box equals 2. It's 3 squared equals 9. Oops, wrong number. And number 16. Log base 9 of -81. You can't take the log of a negative number, so this is, they call it undefined, and it's in capitals, undefined. Okay, capital lock off. Evaluate log of 10,000. We could use our calculator on that if we wanted to, but we don't need to. Look here. This is number 17, log of 10,000. That's log base 10, right? Equals some unknown. So 10 to the box equals 10,000. 10 to the box equals 10 to the 1, 2, 3, 4th power. 4 zeros, so 4. Okay. 18, solve for x. Log base 3 of x equals 2. 3 squared equals x. X equals 9. Changing it into an exponential equation. (19) log base 3 of x equals -4. 3 to the -4 equals x, which is 1 over 3 to the 4th, which is 1 over 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 1 divided by 81. Number 20, solve for x. Log base x of 9 equals 2. X squared equals 9. Use the square root property. X equals plus or minus 3. But recall that the base has to be positive and not equal to 1. So the only answer is x equals 3. X equals 3. What's wrong with that? Well, solve for x. Apparently they don't want x equals 3. There you go. Yeah, sometimes they'll put it outside. And now if you were to have written that on a test and it's marked wrong and I come back, I always look at everybody's wrong answers. I would have marked it correct. Okay, let's see. We need to keep moving here to make sure I get through to some story problems. 22, use a calculator to find the value of x to 4 decimal places. Log of x equals 1.13. This is log base 10. So 10 to the 1.13 equals x. Yeah. And let's see what we get for that. 10 to the 1.13 power, 13.48962883, and it says to 4 decimal places, the 2 would round down. So here, 13.4896. Okay. We've done something like that. So you'd use the A equals PE to the RT for that one. Value to expression is what, 24. Natural log of E equals something. Well, this is log base E of E equals something. So E to the something equals E, which is E to the 1. So the something is 1. Okay. How are we doing? Let's see. We've got. Yeah, I guess we can do some more of these. There's a pattern here, though. So this is 25. Natural log of E to the 8th equals something. We don't know what it is yet. Log base E of E to the 8th equals that. So E to the box equals E to the 8th. The box equals 8. (26) natural log of 1 over E squared. That equals some unknown box. Log base E of E to the -2 power, moving it upstairs. So E to the box equals E to the -2, and the box equals -2. Okay, that's enough of those. Except, what about this one? This would be undefined, wouldn't it? Because you can't take the log of a negative number. Okay, let's take a look at, let's see how many we got here. We're getting close to the end. Okay, and if I have time, I'll go back and do some of the ones I skipped over. Let's take a look at 34. The height of a certain plant is approximated by the function h of a equals 15 plus 20.05 natural log of a, where a is the age in years. How tall will it be when it is 19 years old? So basically, h of 19 would be 15 plus 20.05 times the natural log of 19. So 15 plus 20 times, 20.05 times the natural log of 19. And I get 74.03600153. Nearest inch, 74 inches. Okay. Let's take a look at number 35. Solve the equation. 6 to the x equals 7. Well, I don't know how to take 7 and write it as 6 to some power, but I can take this and rewrite it as log base 6 of 7 equals x. So then x equals log of 7 over log of 6 using the change of base formula. So log of 7, close it up, divided by log of 6, close it up. I get 1.08603, 4 decimal places. The 3 would round down. So you get 1.0860, which is that one. All right, let's take a look at number 36. Solve the equation, e to the x equals 9. So log base e of 9 equals x, but log base e is just natural log. So x is the natural log of 9, which is 2.197224577. 4 places right there, the 2 rounds down, so we should get that 2.1972, so to speak. 2.1972. Okay. Let's see. Good, yes. 37. Solve the equation, e to the negative 0.9 t equals 25. So log base e of 25 equals negative 0.9 t, but log base e would be natural log of 25 equals negative 0.9 t. Divide both sides by negative 0.9, and t is the natural log of 25 divided by negative 0.9. So natural log of 25, close it up, divided by negative 0.9. And we get negative 3.57652. So the 2 would round down, negative 3.5765. Negative 3.5765. Okay, and number 38. A wooden statue found in Egypt has a carbon-14 content that is 4/5 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old is the statue? Round your answer to the nearest 100 years. And this is another problem that a lot of people missed because they didn't do this. You got to read all the directions. Okay. So A equals A sub 0 times 2 to the negative t over h power. We know the half-life is 5,700 years. We want to know how old the statue is. The final amount is 4/5 of the original amount. So if the original amount is A sub 0, the final amount is 4/5 of A sub 0, or as a decimal 0.8 A sub 0. Okay, so we've got 0.8 A sub 0 going in the place of A equals A sub 0 times 2 to the negative t over 5,700 years. We can divide both sides by A sub 0. 0.8 equals 2 to the negative t over 5,700 years. We can now change this to a logarithmic equation. Log base 2 of 0.8 equals negative t over 5,700. Multiply both sides by negative 5,700. And on the right, the 5,700s reduce out. The negative times negative is positive. So t is negative 5,700 times this. But I'm going to use the change of base to rewrite it like that. So negative 5,700 log of 0.8 divided by log of, log of 2, 1834.9. So that would be 1,800 to the nearest 100 years. 1,800 years. Okay, I've still got about 15 minutes, so let's go backwards and do some more problems. How about this one? Number 33. Solve the equation. The natural log of x equals negative 7.1. Well, that's log base e of x, because remember, natural log is log base e. So this would be e to the negative 7.1 equals x. And I can punch that into my calculator. Second ln's, let's see, second. And so I get e to the negative 7.1 power. 0.000825 to sort of 4 decimal places. It would be that. 0.0008. Okay, let's do number 32. Solve the equation. Natural log of x equals 2.748. So log base e of x equals 2.748. E to the 2.748 power equals x. And I can punch that into the calculator. E to the 2.748 power. 15.61137. The 7 would round up, so 6114. 15.6114. Okay. Number 31. Use a calculator to evaluate the natural log of 0.53. We can just put that right into the calculator. Natural log of 0.53, close it up. Negative 0.6348. So the 7 would round up, negative 0.6349. Don't forget that negative sign. Negative 0.6349. And number 30. The natural log of e to the negative 6 power, which is log base e of e to the negative 6 power, and that's equal to some unknown. Changing it to exponential form, we get negative 6. Oh, we can't take the natural log of 0, right? The thing we take the log of has to be positive. So undefined. Let's do this one. We might get through all of them yet. Natural log or the square root of e. Well, that's the natural log of e to the 1/2 power, or log base e of e to the 1/2 power. And we'll set that equal to some unknown. So changing it into an exponential equation, the box equals 1/2. Okay, let's see here. Here we go. Number 23. $10,600 accumulates interest at an annual rate of 8% compounded continuously. How much will be in the account in 60 years? Okay, so we're going to use this formula because it's continuously compounded. So the beginning amount is $10,600. The annual rate of interest is 8% or 0.08. How much will be in the account 60 years later? So A equals 10,600 times e to the 0.08 times 60. So 10,600 times e to the 0.08 times 60. Close that up, and I get 128,801. 0.426. Let's see, 128,801. Okay, so down to two decimal places here, the 6 would round up. So 1,288,010.43. So 1, 288, 010.43. Okay, 22. Let's take a look at 21. Solve for x. Log base x of 1/100 equals -2. Changing this to exponential form, we get x to the -2 power equals 1/100. 1/x squared equals 1/100. 1/x squared equals 1/10 squared. Or you know what? Let's do this. Let's go back here and say x to the -2 power equals 1/10 squared. X to the -2 power equals 10 to the -2 power. So x equals 10. It's probably a little bit easier than the way I was going. So you've got to know your rules. You've got to know how to change from logarithmic to exponential form. You've got to know your exponential rules. Let's see here. Any that I didn't do? Here's one. Okay. Number 11, how much will $10,700 become if it earns 9% annual interest compounded quarterly? Okay, so it's not continuous. So the beginning amount is $10,700. Annual interest rate, 9%. Compounded quarterly, so K is 4, and time is 60 years. So A equals 10,700 times 1 plus 0.09/4 raised to the 4 times 60 power. Okay. I could simplify all of this and all of that, or I can just do it all at once. I'm going to do it all at once. 10,700, oops, 10,700, parentheses, 1 plus 0.09 divided by 4, close that up, little caret key, parentheses, 4 times 60, and I get 231,412.085. We're talking money. So we would round it to the nearest cent, which would be there. The 5 would round up. So $2,231,412.09. 231, 8. What? Okay. So they're giving me an 8. So let's see if I've miscalculated something. All right. 10,700. 1 plus 0.9 over 4 to the 4 times 60 years. Oh, you know what? I'll bet I know why I got it wrong. My calculator gave me this. And I'll bet you that if I'd gone further out, this 5 got rounded up from a 4. That's kind of tricky. How would I resolve that issue? Well, we've got 3 minutes left. I guess I won't resolve that issue right now. I guess I'd look at this and say, well, it's got to be this one because that's the closest one. But again, on my calculator, I don't know if you're understanding what I'm saying with that. So it rounded off right here, which means this 5 was probably rounded up. So it was like 0. Or it was, this was 2.084 something, but then it rounded it up to that. But there's no way of me knowing that just looking at my calculator. So it's a good thing they gave me options there. Hopefully that didn't confuse you. Still got 3 minutes. Let's take a look at this one. So y equals 1/2 to the x power. It's got to be decreasing, so it's got to be this one or this one. But there's no vertical shift there, so it's got to be this one. Okay. 5 to the x power. It's increasing, and the y-intercept is at 1. So it's got to be that one. All right, well, that's it. So be careful what you enter in. Make sure that you're doing the right thing in terms of the function keys and everything over on the right side. You can see I had a couple of mistakes or whatever you want to call them there. Anyway, just be careful. So have a great Christmas and New Year's, and I'll get your grades posted as soon as I can next week. With that, I say goodbye.